welcome to our first class back. As I said last week, we're going to be jumping right into some math here with Chapter 6, Perimeter and Area. Now, of course, before we actually go into that good stuff, we need to make sure that we talk about units and how to convert them. You see, you'll be doing this a lot in this chapter, so it's important that we go over a lot of these things. Now, you're probably at this point wondering, what is a unit and why is it important? So let's answer those before we move on, before we actually go into converting them. So first of all, simply enough, a unit is the standardized measurement of something, right? So I'll give you some of these examples here, and I'm sure you've heard some of these. You've used them throughout most of your life. So yeah, let's go through some of these examples and you'll see exactly what I mean by that. So we first have length, right? The basic one, the first one you most likely learn, and the base unit for that is in meters. Now you'll notice what I've done is I have also put the symbol that's associated with that unit. That's so that if, let's say I'm talking about a 10 meter stick or something, whatever object you want to talk about that's 10 meters, I don't have to write out the unit all the time. I just have to put the symbol, in this case, a lowercase m. Next, we have mass, which you know is grams, lowercase g. Liquid volume, the unit for that is liters. So you might have learned this in science class as irregular, right? How to measure the volume of irregular shaped objects. And you'll notice for this one, the unit symbol is actually an uppercase L. So it does change from time to time, but it's not that, you get used to it. You learn these as you go along, which ones are uppercase and which ones are lowercase. Time in seconds. So you'll have time in seconds, minutes, hours, but the base unit that we mostly use, especially in science, is seconds. And then to finish this off, we go with temperature. And you'll notice I use Celsius here because we are in Canada. We do use Celsius. In the States, they use Fahrenheit. But just like Celsius, we use the metric system. And the United States does not. They use the empirical system. I personally prefer the metric system as someone who has a background in science. I will link to a video right now, so you could click on that if you want to listen and, kind of understand the history of the metric system, why we use it, why some countries don't, all that interesting stuff. So watch it after this class, or actually during your break and after school. If you're interested, you always could come back to this. All right, so now that we know what it is, let's talk about why it's important. And essentially, units are important because it conveys a lot of information, right? So say I see a friend I haven't seen in a number of years, and I bump to them in the streets, and after the conversation, they say, okay, I'll see you in 10. Well, what does that mean? Is that a joke? Like, I haven't seen you in years, so am I going to see you in another 10 years? Am I going to see you in 10 months? Do you know something that I don't? Like, what is your unit here? So obviously to make this conversation a little bit more understandable for myself, I would want to have the actual unit of time. Now, of course, I'm not saying that the unit has to be given every single time. When you go to the grocery store and the cashier gives you your total, she doesn't say that'll be $12.95 Canadian, right? The context kind of says that one, she is or he is talking about money, right? They're a cashier. And two, we live in Canada, so obviously he or she is talking about Canadian dollars, not American, not pesos, not any of that stuff, okay? But if I all of a sudden were to burst into your room and say 150, well, 150 what? What are you talking about, sir? And I could make it very simple for you by putting a simple unit after my number. So if I said 150 kilometers per hour, you would probably understand that one, that's speed, and two, I was speeding, right? So I'm going to get a ticket if that's actually how fast I drive. I don't, by the way, I don't drive that fast. Okay, so another important part of units is that they have to be standardized, or they have to be standard from one place to the other in order to be consistent, right? All that to say, right, is that a meter here in Canada is the same length as the same meter as one in Australia, as one in Japan, as one in South Africa. Anywhere in the world, 1 meter is the same length as another meter. And I think this is pretty obvious as to why you would want that. Because if we're sharing information, right, or you're buying something from another country and you measure your room and you're like, oh yeah, the cabinets are going to look great there. And then you get in, it's like, well, their meter stick was wrong, or my meter stick was wrong. There's a big difference here, and now it doesn't fit, or it's way too small. And it's the same thing in scientific world, right? If we're using these units to actually measure data that is super important from one country to the next, we don't want a big difference in their unit that they're using. Okay, so now that we've answered what a unit is and why it's important, let's go jump into actually converting them. All right, so for this, in this part of the video, what I would want you to do, take the time, pause if you need to, turn to page 216 in your workbook. You'll see at the top something very similar to what I have on the screen. Okay, so you can follow along and put your notes on there right now. So let's start with this diagram. All right, so you'll notice that I have the different words here. Again, this is on page 216. So kilo, hecto, deci, centi, and milli. These are my prefixes, meaning these are the words that come right before the base unit. And you'll notice I've left the base unit blank here. I've just written base unit. That's because any unit could fit in there. And I'll show you that in a second. Okay, so we'll talk about that in a second. The next thing that I want to say is 1. If you look to the right, deci, centi, milli, these are your smaller units. So you use them to measure small things, right? If you want to measure a paper clip, I don't know why you would want to do that, but hey, if you want to do it, go ahead. You would probably use either millimeters or centimeters, right? You wouldn't want to use the kilometers, hectometers, and decimeters. And the reason why, I'll let you think about it for a second, but the reason why, which I think you already know, is because you'd have an extremely small number. You'd have 0.0000, depending how small the thing you were measuring. And you don't want that. It just doesn't look nice, right? And on the flip side of things, if we look on the left side of our diagram, that's where we're going to see our bigger units. So it's the opposite problem. We don't want to measure a road, like a stretch of highway. We would normally do it in kilometers. We don't want to do it in millimeters. And the reason why is because that number would be gigantic. It wouldn't fit on the boards on when you drive on the highway, you see those boards that say next exit in 2 kilometers. Imagine you would read it and it would just be a trail of zeros. It would be very difficult to read, right? So depending on the context, if we're talking about something long, we tend to go on, or for measurements, length anyways, something long, we tend to stick to the left side. If it's something very small, we tend to use the units on the right side. Okay, so what I was talking about the base unit is I could put anything in there, in that middle. So for example, if I put a liter in here, well, now everything changes. So it goes from liter, no prefix, to deciliters, centiliters, milliliters. Same thing on this side, deciliters, hectoliters, and kiloliters. Okay, and we could do the same thing with grams. I won't go through every single one of these, but you know what I mean. And then meters. So millimeters, centiliters, decimeters, decimeters, hectometers, and kilometers. Okay, and now we're going to stick to the meters. In science, you're going to use liters and grams, but for math, we're really, for this year, only working for meters. So this is the diagram I'm going to use from now. Okay, so when we actually want to convert, if we're going from the right side to the left side, every step I take, so starting here in this particular example, if I started millimeters and wanted to convert to centimeters, I would just take that number and divide it by 10. So for example, off the top of my head, numbers that are easy. If I have 80 millimeters and I want to find how many centimeters I have in there, I would take that 80 millimeters and divide that by 10. So 80 divided by 10 would give me 8 centimeters. Now, the cool thing about this is you can stop, pause the video right now, look at a ruler, and see that that's actually the case, right? You would actually see that you have 80 tiny little notches, and that would be the equivalent of 8 centimeters. We could bring this further. Of course, we can say for every other step after that, we would just divide by 10, divide by 10, so on and so forth. Okay, so if you're going from millimeters to decimeters, you would take that number, 80 again, divided by 10. We know we have 8 centimeters, like we said. If I want to know the number of decimeters, I would divide it again by 10, and that would give me 0.8 decimeters. All right, and then so on and so forth. I could go all the way to kilometers, but I don't want to waste your time. So the opposite way is the exact same thing, except instead of dividing, we're multiplying. So if I have, for example, I don't know, 200 kilometers, and I want to find out how many hectometers that is, all I would do would be multiply by 10. So 200 kilometers times that 10 would give me 2,000 hectometers. Okay, as I go this way, my numbers should increase. So, like I said, multiply by 10 once. Another step, you would multiply 10 again. So if I had 200 kilometers, I know I have 2,000 hectometers. And if I want to see how many decimeters I have, I would multiply by 10 again, and that would give me 200, 2,000, 20,000. All right, and so on and so forth until we get to the millimeters part. All right, guys? So I know there's a lot here. Take some time if you need to, a minute or two, write this into your workbook, and then we'll jump into some examples right after. All right, so example 1, how many centimeters are there in 25 meters? So what we're going to do, we're going to take our diagram. Also, I failed to say this before, but there's actually a really good trick to remember this. It's King Homer didn't, King Homer died, Marge didn't care much, okay? So I forgot it a bit, but King Homer died, Marge didn't care much. So that's a little trick that you could use to remember the order of these things. Okay, so let's actually move on to solving this problem. So if I have 20 meters, I would start right here, and I am moving to the centimeters part. So I need to get from here at the meters all the way to here. So that's 2 steps. And every step, like I said, you're multiplying by 10. So solution, 25 times 10 times 10. Now, the reason why I put these brackets around here, right, is because the step should be done first. And every step in here should be multiplied. And you'll see in the next example what I mean by that. The symbol here, in this case it's multiplication, changes depending if you are going right or left. In this case, we're going to the right, so it's a multiply symbol. It's a times symbol. All right? But anytime we have our brackets, our actual tens, we're always going to multiply. All right? So that's going to give us 25 times 100, and our final answer would be 2,500 centimeters or 2,500 centimeters. Okay, so let's go to example 2 and go the other way. How many decimeters, so be very careful with decimeters and decimeters. They look almost the exact same. This one is with an A and the other one's with an I, so it's literally 1 letter difference. So how many decimeters are there in 25 centimeters? So again, let's bring up this diagram. We know that we are starting at centimeters, and we're moving to the left, and we're finishing at decimeters. So let's show that. We are doing 3 steps. I'm going to show you a really, really simple trick with this in a second. So my solution, I have 25 centimeters, right? And now, because I'm going to the left, I am dividing. But you'll notice that inside these brackets, I am still multiplying them, right? I'm not going to go over why, right? Because if I didn't have these brackets, it would be a division each time. But you would go from left to right. You could try this at home on a calculator. You can do 25 divided by 10, divided by 10, divided by 10, and you'll see you'll get the same answer. This kind of simplifies everything because here, right, instead of doing 25 divide by 10, get an answer, divide by 10, again, get an answer, and typing it a third time, divide by 10, and getting your final answer, you could skip that by just doing 25 divided by 1,000. And you'll notice this little trick. When you are dividing or multiplying to change the unit, to convert your unit, you always have a 1, and then the number of zeros depends on how many steps you take. So you'll notice that I have 3 steps here, and I have 3 zeros after the 1. And if you go back to example 1, you'll actually see that. I did 2 steps to the right that time, but still 2 steps, and I had a 1 followed by 2 zeros. Okay, so that's a really easy trick to save you some time. All right, so I have 25 divided by 1,000. When we go through that, we get our final answer, which is 0.025 decimeters. And this is the symbol for decimeters. It's just has it's 3-letter symbol, and it has an A in the middle. Decimeters over here would just be a D and an M. All right. So again, take some time if you need to, look over everything. And then when you're ready, go to example 3. Example 3. So this one's going to be a little bit different because we are going to work with perimeter, all right? But it's a very simple one. So the question is, if a rectangular frame is 2.5 decimeters, so that's what I was saying before, right? Just a D and an M for decimeters. So if we have one side is 2.5 decimeters, and another side is 150 millimeters, what's the perimeter in centimeters? So I'm having you do a couple of things here. One, you'll notice that the 2 units that are, the 2 measurements that are given to me are in units that I can't just add. You cannot just add 2.5 decimeters to 150 millimeters. It won't make sense. You need to make sure that they are in the same unit. Now, I don't give you much of a choice here because I'm telling you that I want the perimeter in centimeters. So what you're going to do, you're going to do 2 steps. So let's have our diagram ready. Let's start with the first part of our solution. So first, I'm going to convert this 2.5 decimeters into centimeters. So again, I go through my routine. I start at decimeters and I move to my right, multiply by 10 when I do that. So 2.5 times 10, and notice it's only got 1 0 here because I only moved once. Okay, so our trick still works for that. So 2.5 times 10 gives me 25 centimeters. Now moving on to part B, let's convert 150 millimeters into centimeters. So again, I'm moving only 1 step, but this time to the left. And because I'm moving to the left, I'm dividing by 10 instead of multiplying. So I write it out as this, 150 divided by 10, that gives me 15 centimeters. Now, since I have both measurements, width and length, or height and length, whatever you want to call it, in centimeters, I can add them. So that's my third part. 25 plus 15 gives me 40 centimeters. And that's it, right? Wrong. remember, what I've done is I've taken two sides, only two sides. It's a rectangular box, it's a frame, right? It's going to have four sides. So if I have one side that's 25 centimeters and another side that's 15 centimeters, since it's a rectangle, I know I have another 25 centimeters on the opposite side of this one, and on the opposite side of the 15 centimeter side, I have another 15 centimeter side. So once you get this answer, remember you only have two sides, you would just have to multiply by 2. And you would get your final answer when you go through that multiplication, you would get a perimeter of 80 centimeters. So that's it for today. I want you to now, if you need to, rewatch this video in certain parts. And once you're done with that, once you think you have a good grasp of the material, you can go do that small quiz. The link is on the Google Slide interactive whiteboard. All right, so go back to that, click on the link, go fill that out, and when you're done with that, I'll be waiting on the Zoom call. So I'll see you in a little bit. Bye, guys.